Okay, so in this video, we're going to be talking about finding the intercepts of a line. So before we start going into the problems, we first have to talk about what are the intercepts. So if you have a coordinate grid, I'm going to go ahead and draw that right now. Okay, here is our y-axis, here is our x-axis, right? And let's go ahead and put a line on it. So it doesn't matter the direction of the line, the slope could be positive or negative, it does not matter. So I'm just going to go ahead and put on a line. There it is, right? The best of my ability, right? Not very straight, but it is what it is. So the intercepts are going to be where it's crossing the y and the x-axis, okay? So if you look at this point right here, okay, that's going to be considered your y-intercept value. This point right here is going to be considered your x-intercept value. Now these points can be represented by the following x and y values. So for your y-intercept, you know that the coordinates are going to be 0, y. Okay? And for your x-intercept, the coordinates are going to be x, 0. So what this is saying, you know, x and y could be anything, okay? But if you're finding the y-intercept, this right here, your x value, will always be 0. And if you're finding the x-intercept, that means that your y value will always be 0. Because if you think about it logically, right, at this point here, it's where it's crossing the y. And whenever you cross the y-axis, the x value will always be 0. Hence why we're putting a 0 here. And whenever you're crossing the x-axis, the y value will always be 0. Hence why we're putting a 0 here. So that is the x and y intercepts. It's really easy. It's just where it crosses the x and y axis, okay? And we can also use it for graphing purposes. If I have 2 points that I can find, such as the x and y intercept, I can go ahead and graph that way. So rather than graph a line in slope-intercept form, we can graph by using the intercepts. All right, let's take a look at the first problem. Okay, so here is our first problem, and they want you to find the intercepts here. Now let's talk about how we're going to do this. If you go back to that previous example I just gave you where we drew the line on the coordinate grid, we know that where it crosses the y-axis, that's going to be our y-intercept, the x value will always be 0, okay? And where it crosses the x-axis, that will be our x-intercept, okay? The y value will always be 0. So in this case here, if I want to find the x and y intercepts of this line, all I have to do is plug zeros into x and y. Now, before I do that, I want you to take a look down here. This equation that we're working with right now is in standard form. You can see that I wrote it down here where it says ax plus by is equal to c. So a and b, those are just coefficients in front of your variables, in this case x and y, and c is your constant. That's called standard form. So this equation right here is not in slope-intercept form, which is y equals mx plus b, right? Most of you know how to graph when a line is in slope-intercept form, but if I were to give you a line like this and I told you to graph, right, some of you may have difficulty. This is where finding the intercepts really comes into play, because I can graph using the intercepts, okay? So this line that we're provided with is in standard form. It is not in slope-intercept form. So let's find the x-intercept first. So all I'm going to do is write x, and I'm going to abbreviate here int for intercept, okay? How do I do that? Well, it's really simple. All you have to do is plug a 0 into y. So I'm going to rewrite the equation 2x plus 3 times 0, here's my 0, right, equal to negative 12. And so what happens here? Well, this will cancel out here. Here I get 2x is equal to negative 12. Divide both sides by 2, okay? What do we end up with? We get x is equal to negative 6. Now that's a point, okay? That is a point that we could put on a coordinate grid if we wanted to graph it. This would be negative 6, 0, okay? Why don't we go ahead and box that in? There is the x-intercept. Now, how do I get the y-intercept? Well, I do the same exact thing, except now I'm going to plug it into x. So for the y-intercept, all I'm going to do is plug it into x. So I'm going to have 2. Here's my x, plug in a 0, plus 3y equal to negative 12. If we divide both sides by 3 now, we know that we're going to get negative 4 for y. So that's a coordinate. Y is equal to negative 4. I can write 0, negative 4. Okay? And so if you were given a coordinate grid, you could go ahead and graph the line now, and you're not even in slope-intercept form, okay? So real quick, if I make a real quick coordinate grid here, right? Doesn't have to be perfect. Here's y, here's x. Let's put that first point on -6, 0. So 1, 2, 3, 4, 5, and 6, -6. There we go. Make a point there. And then the other one is 0, -4. So 1, 2, 3, 4, -4. Make a point there. And then we're just going to connect it to the best of our ability, right? Now, again, this is just an example. So typically you'd want to use a ruler here. But, you know, for this example, we're not going to use a ruler. Plus, I'm doing it on my computer. I'm not really sure how to do that. And there we go. Okay. So this tells me a lot of information. When I look at this equation right here in standard form, when I graph it, I know that the slope is going to be negative just by looking at this line. This is a negative slope, right? So it tells me a lot of information here, and I was able to graph it just by using those 2 points, the x and y intercepts. I did not have to take this equation that was in standard form and then rearrange it into slope-intercept form and then graph it, right? So here's the rule of thumb. If you're given an equation in standard form like we have here, and the problem is asking you to graph it, you're going to want to graph it by using the intercepts, by using the method we used here. It's going to save you way more time, and you don't have to rearrange it into slope-intercept form and then graph. Okay? So that is pretty much all you have to do when solving for the intercepts. Let's go ahead and try another problem. So here's another problem. I'm going to go ahead and find the x-intercept first. So x-intercept, again, abbreviating. And again, remember, you're just plugging a 0 into y. Now, as you progress in these problems, you really don't even have to plug in a 0. All you have to remember is anything that's attached to y, this whole thing's going to cancel out, right? Because I'm going to be multiplying by 0. I'm going to be left here with x equals 8. Okay, so for example, you would write x plus 2 times 0 equal to 8. Now you know you're plugging in a 0, so this whole part right here, technically, you don't even have to write because you know it's just going to drop out, okay? You're just going to be left here with x equals 8. So writing out this point, it's going to be 8, 0. There it is. There's that one. That's the x-intercept. The y-intercept, we can do the same thing. Now let's think about it logically. That x is just going to drop out. I'm going to plug in a 0 into this x here, right? I'm going to be left with 2y equal to 8. So 2y equal to 8, and then I have to divide both sides by 2. I get y is equal to 4. And then we have coordinates now, right? So the coordinates here would be what? 0, 4, right? And again, if you want to graph that, you can go ahead and graph it. Okay, here's the next problem. Let's go ahead and find the x-intercept. So x-intercept, here we go. What do we get there? So again, I'm going to be plugging in a 0 into y. Now again, I told you, you could just drop it out if you want, or you can keep writing it until you feel comfortable, right? So minus 0, here's my y, right? Equal to 4. This is gone. I get 4x equal to 4. Divide both sides by 4, you get x is equal to 1. Let's write it as a point though, as a coordinate, right? So 1, 0. There it is. There's my x-intercept. Now to find my y-intercept, here we go, y-intercept. This one here, we're just plugging a 0 into x. Again, if you just want to drop out this whole part here, you can, or you can rewrite it. I don't care how you do it, right? Doesn't matter. So 4 times 0, there it is, minus y equal to 4. This whole part drops out like we talked about. Now be careful here, you have negative y equal to 4. We're not done yet. I cannot leave this negative right here. I have to get rid of it. Now what's really going on there is you have a negative 1 times y equal to 4. So you're going to have to divide both sides by negative 1. That will get rid of the negative. 4 divided by a negative 1 will give you negative 4. So y is equal to negative 4. Okay? So this just becomes 0, negative 4. And so we talked about this in the last video. If you go back and look at the point where we were right here, where I had negative y equal to 4, if you're solving an equation and you're left with a negative variable at the end, all you have to do is change the signs on the opposite side of the equal sign. So if I have a negative y here, I want it to say y equals. That means the end result will be y equals, and change this sign right here, which is technically positive. You would change it to negative, hence our answer here, y equals -4. So just something you can keep in the back of your mind. You don't have to do this step that I did down here by dividing by -1. You just know that it's going to end up changing the signs, okay? All right, let's try one more problem. Okay, so here's our next problem, and we have a fraction here, but honestly, you don't have to worry about it. It's not that bad. So first, let's go ahead and find the x-intercept. That looks like the more challenging one. So just writing x-intercept, int for intercept. We're going to put 5x all over 2. Now again, I'm plugging in a 0 here. So again, the thing's going to drop out, but I'll write it anyways. Okay, this is gone. I'm left with 5x all over 2 equal to 7. My next step, well, what do I have to do here? Remember, the goal is to isolate x, meaning I'm going to have to get it to the point where I just have 5x, okay? So how do I do that? Well, I have to get rid of 2. And this operation here is division. The opposite of division is multiplication. So I'm going to multiply both sides by 2, okay? Cancels, cancels. I get 5x equal to 14 now. 5x equal to 14. My last step, divide both sides by 5, and you get x is equal to 14 all over 5. And we're going to leave it just like that as an improper fraction. No need to write it as a decimal. We don't want to lose accuracy. Let's leave it just like that. So as a point, what does that look like? Well, it's going to be 14 over 5, comma 0. There it is. Okay, let's do the y-intercept now. This one's a little bit easier. No fraction. Because what's going to end up happening, the fraction is going to cancel out, right? But again, we'll write it here anyways. 5 times 0, again, plugging a 0 into my x, minus 7y equal to 7. So again, this whole part is going to drop out here, right? It's 0 divided by 2, just cancels out, right? And here we have negative 7y equal to 7. So my last step here, I have to get rid of that -7. It's multiplication, divide by a -7. And so what ends up happening here? This will cancel. A positive divided by a negative is negative. So 7 divided by a -7 is -1, okay? So y is equal to -1. Writing that as a point now, I'll have 0, comma, -1. Done. So that is finding the intercept, okay? It's really not that difficult. All you're doing is plugging in zeros into either x or y, and that's really all there is to it. And also just keep in mind, this can be applied to not just linear functions, but it can also be applied to quadratics, cubics, quartics, and so on. It can be applied to any polynomial. The only thing is it won't be as simple as what we're doing right now. You may have to factor, right? And that's going to come into play later on as you move into Algebra 2. But as for now, we're just working with linear functions. It's pretty simple to find the intercepts, as you can see here, okay? So that is it. I hope that you found the video helpful. I hope that you gained something from it. And as always, if the video helped you, please go ahead and give it a thumbs up. And also make sure you subscribe for more math videos in the future, and I'll see you in the next one.